Hello. How are you guys? Good morning, geometry class. We're going to go ahead and continue with section 11.1. Today we're going to do 11.1. Tomorrow's lesson will be 11.2, and then we are done. That is everything that we're going to need to learn for this final exam and for the rest of the year. We're done. All right. So, yesterday we talked about circumference, and we also talked about what pi is. All right. Today we're going to talk about arc length and radians. All right. So, we're going to start with a definition for arc length. So, what is arc length? Well, arc length is just a portion, which portion is just another word for piece. All right. Of a circle's circumference. All right. So we learned about circumference yesterday. Arc length is just a piece of the circumference. All right. So what does that mean? Well, again, let's imagine that we have a circle here. I'll draw a circle. All right. Here's a circle. Excuse me. All right. Well, an arc length would just be a piece of this circle. So maybe if I take from here to here, all right, and I take this piece of the circle, all right, this. Now we've already said that this piece is called an arc, all right. All right. And the arc length is just how the distance of the arc, all right? How long is this line? All right. If we straightened it out and we measured it, how long would it be? All right. Now, real quickly, I'm going to also draw the center of this circle. All right. It's probably about right here. All right. So here's our center. All right. And we could also draw radii starting from the center and out to here. And then also another one. Let's do another one from the center out to here. Okay. So this distance right here is the arc length. All right. It's a piece of the circumference. So the circumference is the distance all the way around the circle. Start here and we go all the way around the circle. That is the circumference. But if we just take a piece of that, that's arc length. All right. Arc length. And we are going to learn a formula to help us find the arc length. All right, so actually, why don't we do that right now? I'm going to come down here onto the next page, and we're going to talk about the arc length. All right. So if we want to measure the arc length of a circle, all right. So here's the arc length. The way we find it is this formula right here. Right now, it might look a little confusing, but it's actually not too hard. All right. So, what is MAB? It's the measure of the arc AB. And remember, last chapter, we learned the measure of an arc is the angle that is made right here. All right. What is this angle? All right. So we find that angle. Let's say for this one, let's pretend it's 90 degrees. All right. All right. For this one, let's say it's 90 degrees. All right. So what we do here is we just have 90 degrees divided by 360 degrees not equals. It's going to erase all of it. Dang it. I knew it. 90 degrees divided by 360 degrees times 2 pi r, where r is the radius. All right. So if I told you, let's imagine that r is 2. All right. Let's say the radius of this is 2. Okay. Well, then if we want to calculate the arc length, it's going to be 90 divided by 100 by 360, which is 1 over 4 times 2 pi, and we said the radius here is 2, so we're going to say 2 because it's 2 pi r, right? 2 pi 2. All right, so that is 2 times pi times 2 is 4 pi, and we want to multiply that by 1 over 4. Well, these 4's are going to just cancel out, and we're going to end up with just pi, all right? So this distance from here to here is pi, all right? If we know that this is a 90-degree angle and the radius is 2, then this arc length is pi, all right? Because when we put it into the formula, that's what we get. And remember, pi is just a number, all right? Don't go, oh, pi is some, this is just a number. Remember, pi is just 3.1415 9, all right, blah, 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 blah. All right, this distance here is just 3.14159, blah, 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 blah. All right, it's just a number. Don't think, oh, pi is something strange or anything like that. It's just a number, all right? All right, you can have number 2, number 4, number 3.5, number 76, and you can have the number pi. It's the same thing, all right? Excuse me. Okay, so that's how we use the arc length formula. We're going to do a couple of examples from the book on using the arc length formula. Let's do an example here in the notebook. All right, so here it says we want to find what is the arc length of AC. So we want to find what is this distance from A to C. What is this distance, the arc length? All right. Well, we're going to use the formula that we just learned. All right. What was the formula? It's the measure of the arc. All right. So the measure of AC divided by 360 degrees times 2 pi r. Remember, 2 pi r is just the circumference of a triangle, of a circle. All right, so let's put everything in. Well, what's the measure of AC? It's this angle, and they already told us what it is. It's 70 degrees. So this is going to be 70 degrees divided by 360 degrees times 2 pi r. Now, what is r? Well, here it says it's 3. 3. Okay. So let's calculate this out. Well, 2 times 3 is 6, right? These two things multiplied together is 6, all right? And 6, we can actually cancel things out here. So this is going to go away, which means these are going to go away. And then 360 divided by 6 is 60, all right? So we have 60 degrees down here, 70 degrees on top, and then the pi is left over, right? So 70 divided by 60 is 7 over 6, all right? And then we just have pi left over, pi, all right? So this is a 7. All right, so 7 over 6 pi. That is our answer, all right? 7 over 6 pi, okay? Pretty easy, all right? That's just using the formula. Let's look at a couple more examples because the notebook only has this one example, but I think we should do a couple more. Let's look at a couple of examples in the book, all right? So this one, they're not asking us to find the arc length, all right? The arc length here, they already told us. It's 4.19. They want us to find the circumference, all right? The circumference. Well, remember, what is the arc length formula? So the measure of the arc xy. This is the xy is the arc right here. So the measure of the arc divided by 360 degrees times 2 pi r is going to equal the arc length, all right? Which in this case, they already told us is 4.19, all right? So we know this is true. But I want you to look here. We want to find the circumference, right? We want to find the circumference. Well, look, this 2 pi r, that is the circumference, right? That is the circumference. So we want to find what is this, all right? Now, if we want to find this, we need to find, well, we don't even need to find the radius, all right? The radius isn't necessary right now because we already have the arc measure, all right? The measure of the arc is 40 degrees, all right? So this right here is 40, all right? So that means what we can do is we can say 40 degrees over 360 degrees times 2 pi r, which is c, which is what we want to find. We want to find the circumference, equals 4.19. All right? All right, well, look, 40 divided by 360 is actually 1 over 9, right? So 1 over 9 times c equals 4.19, all right? Which means that c is going to equal 4.19 multiplied by 9, all right? So let's calculate this out. Let me grab a calculator out real quick. Calculator. All right, so we have 4.19 times 9, and that equals 37.71. All right, so that's 37.71. And they gave us a unit here, inches, so we're going to write inches. So that's the answer. All right, the circumference is 37.71 inches. All right. Oh, real quickly, I think I forgot on this one, I didn't put the unit. Here is inches, so this is also inches. All right, so make sure you always put units down. All right, good. So that's how you do this one when they want to find what is the circumference. All right, let's look at another one. Let's look at this problem, C, where they give us this distance from here to here. The radius is 15.28. And they gave us the arc length is 44. And we want to find what is the measure of the arc. So what are we looking for? The measure of the arc is this angle. We want to know what is that angle. Well, again, let's come up here. What is our formula? Well, we know that the arc length, which is 44, so 44 is going to equal, and what is the formula? The measure of the arc, all right, which is arc RS, all right, so measure of RS divided by 360 degrees, and then that's times 2 pi r, which they already told us is 15.28. All right? So now we can use this to find the measure of this arc. All right? That's the only thing we don't know here. So what we're going to do, let's see here. We're going to say 44 times 360, because if we want to get rid of this on the bottom, we have to multiply. All right, so 44 times 360 degrees, and we're going to divide by this, 2 times pi times 15.28. And that will leave us with the measure of RS. All right. All right. So we can calculate this all out. All right. We can calculate this out. We can just use a calculator. All right. So here we go. I'm going to say 44 times 360 equals, and then I'm going to divide by all of these things. So I'm going to put parentheses and then do 2 times pi times 15.28, then close the parentheses and hit equals, and it gives me 164.987. 7 is bigger than or greater or equal to 5, so we're going to round up. So it's going to equal 164.99, right? Is that what it was? Yeah, 164.99, and that's degrees, all right? That's the measure of the angle, all right? So that's the answer, all right? Pretty easy, okay? So that's how we do these. That's how we use our arc length formula. So you need to know this arc length formula, all right, to find arc length, to find circumference, or to find the measure. All right. We could also find a radius if they wanted us to find the radius, or if they wanted us to find a diameter, we could do that because 2 times r is the diameter. So this also is the same as pi times d. All right, right? Because 2r equals d. All right. Okay, so that's how you do that. Now we're going to learn one more thing today. All right. We also need to learn what is a radian. All right, so we're going to do one more definition. All right. So what is a radian? Well, a radian is just a way of measuring angles. It's just a unit. If I want to measure how long something is, all right, if I want to measure how long something is, I could use centimeters or meters, or I could use feet or inches, or there are many different units, all right? Well, same thing with angles, all right? If I want to measure an angle, I can use degrees. That's what you guys already know how to use. But there's actually another thing that we can use. It's called radian. It's another unit for measuring angles, all right? So it's another unit used to measure angles, all right? One circle, which is 360 degrees, is 2 times pi radians. All right. All right. 2 pi radians. All right. So one circle is 2 pi radians. All right. So if I wanted to measure all the way around this circle, I would say it's 2 pi radians. Now we don't write radians. It's actually, it's a unitless measure. You don't put radians at the end, so don't worry about that. But just write 2 pi. The measure of the angle is 2 pi if it's all the way around. So we want to know, how do we switch back and forth? How do we take, if I know degrees, can I change it? If, for example, if I know how many centimeters something is, I can change that into meters, right? 150 centimeters is 1.5 meters, all right? You can do that. But we also, with angles, we need to be able to change. If I know it's 60 degrees, how do I change it into radians, all right? All right, so how do I go from degrees into radians or radians into degrees? All right, so let's look at an example of how to do that. All right, well, we need to know this formula. All right, if we want to change from degrees into radians, all right, so if you know the degrees, All right. If you know degrees and you want to change into radians, all right, we're going to use this rule. We're going to actually ignore this one. All right. Let's just focus on this one. I think it's easier. All right. They're both the same. All right. But we're going to multiply the degrees by pi over 180 degrees. What does that mean? Well, let's do an example. Let's say I tell you, oh, we have 90-degree angle. All right, we have a 90-degree angle. We want to change it into radians. So I say, what is 90 degrees in radians? Well, all we have to do is multiply by pi over 180 degrees. That's it. Well, what do we do here? This is going to go away. This is going to turn to 2, all right? So this just ends up equaling pi over 2, all right? So pi over 2 is the same as 90 degrees, all right? 90 degrees is pi over 2 radians, all right? That's how we switch it. Let's do another example. What if I say 60 degrees? All right. What if I say, oh, what is 60 degrees in radians? Okay. Well, we're just going to again, we just multiply by pi over 180 degrees. All right. Well, this is going to go away. It's going to become 3, right? 180 divided by 60 is 3, right? So what are we left over with? We just have pi over 3, right? Pi over 3. So that's the answer. If I want to take 60 degrees and change it into radians, it's pi over 3 radians. All right, that's it. All right, that's all you have to do. All right, then sometimes you might know the radians and you need to change it into degrees. All right, also very easy. All right, if we want to change from radians into degrees, how do we do that? Well, again, ignore this one. All right, they're the same thing, but I think it's easier just to remember this one. All right, we're just going to multiply by the flip. All right, 180 over pi. All right, so for example, if I told you that we have a 5 pi over 6 angle, all right, I tell you 5 pi over 6 is the radian measure of the angle. What is that in degrees? All right. Well, all we have to do is multiply by 180 degrees over pi. All right. And that will give us our answer. So let's do that. All right. So pi's are going to go away. No more pi's. Then here we have 6, and here we have 180. Well, 180 divided by 6 is 30, all right? So this is going to be 30 up here, 30 degrees. All right, so we're going to have 5. So everything's gone except for 5 times 30 degrees, which is 150 degrees, all right? And we're done. That's the answer. 5 pi over 6 radians equals 150 degrees. Okay? Simple. All right, we're going to do a couple of examples in your book, in the notebook. All right? And then that's it. I'll give you a homework assignment online. All right, so the first one says we want to convert 60 degrees to radians. Oh, dang it, they already did 5 pi over 6. Did I already do both of those? Dang it, I did both of those already. I just picked 2 examples and they happen to be the exact examples that were here. Okay, anyway, we'll do it real quickly over again. Same problems. So 60 degrees. We want to convert to radians, so we're going to multiply by pi over 180. All right? That's it. All right? 180 divided by 60 is 3. So the answer is just going to be pi over 3 radians. That's it. And you don't need to write radians after it. All right. All right. So done. All right. And then 5 pi over 6, same problem we already just did. All right. But I'll do it real quickly over again. 5 pi over 6, we want to convert it to degrees. To convert to degrees, we multiply by 180 over pi. All right? And then we just very quickly say, okay, well, pi's are going to cancel out. 180 divided by 6 is 30 degrees. All right? So we're left with 5 times 30 degrees, which is 150 degrees. So that's the answer there. Okay? So that's how you convert from degrees to radians and radians to degrees. All right? You'll have some problems like that on your homework tonight. You will also have some problems on finding arc length or using the arc length formula to find circumference, radius, or diameter. All right. Bye-bye. If you have any questions, let me know. Talk to you tomorrow for our last class.